All right, let's talk about one of the biggest secrets in professional software design. It's this one simple shift in thinking that honestly separates clean, scalable code from those brittle, confusing messes we all hate dealing with.
And we're going to start with a super simple question. Seriously, no tech involved, forget about code for a second, and just answer this for me. Is a car an engine?
Of course not, right? The answer is a big no. I mean, that's totally obvious. An engine is part of a car, but it's not the car itself. Simple.
Okay, cool. Let's try one more just to really hammer this home. You ready? Is a car a wheel?
And again, nope, not even close. A car uses wheels to get around, but it definitely isn't a wheel.
Okay, so here's the big idea. The whole point of this. A car isn't an engine. It isn't a wheel. A car has an engine. It has wheels. And that simple idea, that little phrase, has a, that is the core concept that is gonna completely change how you write code. I promise.
So let's take that simple idea and see how it translates into the world of software. It really all boils down to two core relationships, is a versus has a.
And this is where that real-world logic maps perfectly to our code. On one side, you've got inheritance. That's your is a relationship. A student is a person. A dog is an animal. It feels natural, right? But then, on the other side, you have composition, which models our has a relationship. A car has an engine. A house has a room. And knowing when to use which one, well, that's the whole game.
Now, that is a relationship, inheritance, it often feels like the default, the first tool you reach for. But honestly, it can be a massive trap. So let's look at a classic textbook mistake where using inheritance just completely breaks all logic. Okay, so check out this code. At first glance, it seems totally fine. We make a bird class, and we give it the ability to fly. Then, since a penguin is a bird, naturally, we have the penguin class inherit from bird. Makes sense, right? Simple.
But hold on a second. What's wrong with this picture? Well, last I checked, penguins can't fly. So our design, which seems so neat and logical, has actually created something that's just wrong. It doesn't match reality. We've literally forced our penguin to inherit a behavior it just doesn't have.
So, how do we fix this mess? How do we solve this logical puzzle? This, my friends, is where the power of composition comes to the rescue. It lets us build our objects from different parts and behaviors, creating a system that's way more flexible and, actually makes sense.
And here's the solution in action. It's beautiful. Instead of forcing a penguin to be a flying thing, we pull out that ability to fly and make it its own separate component, a fly behavior. Now, a flying bird has one of these. Our penguin, it simply doesn't. See? We've modeled reality correctly by building our objects from the things they can do.
Look, this approach is just better. For so many reasons. Your design becomes incredibly flexible. You can swap behaviors in and out. It's way more accurate to the real world. The parts are replaceable, just like swapping the engine in a car. And, this is a big one, it makes every little piece of your code so much easier to test all by itself. Okay, so we've seen the problem and the solution in one specific example. Now let's zoom out a bit. Let's create a sort of professional's rulebook so you know exactly which tool to grab from your tool belt and when. And you are definitely going to want to pay attention here because we're about to reveal one single powerful rule of thumb that, I'm not kidding, fixes probably 80% of the design problems that trip developers up. All right, here it is. Tattoo this on your brain. The big takeaway is this: inheritance for classification, composition for behavior. Let me say that again. Use that is a relationship only when you are truly classifying something, like a dog is an animal. For pretty much everything else, especially defining what an object does, you should be thinking has a and using composition. So let's break that down just a little more. You reach for inheritance, the ISA model, when it's a true classification, when a behavior absolutely must be shared, and when the whole parent-child thing just makes perfect logical sense. But for everything else, when an object is built from different parts, when its behavior could change, or when you just need maximum flexibility, you're going to use composition. Every time. So there you have it. By really getting the difference between what something is versus what something has, you now hold the key. This is how you design clean, flexible, and truly professional-grade systems. So, the next time you're sitting down to design something new, I want you to stop yourself. Don't just ask, what is this thing? I want you to ask, what does this thing have? So the real question is, how are you going to use this has a relationship to make your very next project even better?